Good morning, students. In previous class we have learned atomic mass, molecular mass, mole and molar mass. Okay, and molar value also we discussed. Now today we will discuss about equivalent mass, or it is also called equivalent weight. Okay, so generally it is one of the example. It is a salt reaction, that means neutralization reactions. That is, acid is reacted with the base to form a salt as well as the water. So this is a balanced chemical reaction, and how it can express according to moles, we can express 1 mole of H2SO4 is reacted with 2 moles of NaOH to form 1 mole of sodium sulfate as well as the 2 moles of water will be formed. Okay, so according to a chemical reaction, according to expression in a moles, so here we can express the 1 mole of H2SO4 is reacted with 2 moles of NaOH to form 1 mole of sodium sulfate as well as the 2 moles of water will be forming. Okay, so whenever according to expression in equivalent mass or in equivalent weight, so how can it express? So equivalent weight of one equivalent weight of H2SO4 is reacted with one equivalent weight of NaOH to form one equivalent weight of sodium sulfate plus one equivalent weight of H2O. So this is the beauty of equivalent weight. So okay, so whenever we express in the moles, different moles are combining. Okay, so here different moles are combining to form a different moles of products. But whenever the same balanced chemical equation, whenever expressed in terms of equivalent, all are equivalents. So that is the beauty of equivalent. So here whenever we expressed in the equivalent weights, there is not necessary for balancing the reaction. Okay, but whenever expression in the moles, here balancing the equation is very important. But here whenever we express it in the equivalent weight, it is not necessary. Okay, so already here see that what is the one equivalent weight of H2SO4 is reacted with one equivalent weight of NaOH to form a one equivalent weight of sodium sulfate plus one equivalent weight of water. So that is the beauty of equivalent weight. Whenever we express the chemical reactions in a equivalent weight, there is not necessary for balancing the reaction. Okay, so that's why we should learn the equivalent weight of a element or any one of the substance. Generally we call it as a substance. Now we will see the definition of the equivalent weight. So here in number, which denotes the mass of substance that will combine or displace 1.008 grams of hydrogen or 8 grams of oxygen or 35.5 grams of chlorine is called equivalent mass or equivalent weight of the substance. Okay, so it is nothing but, don't worry, don't confuse here. Equivalent weight is one of the number. Okay, so it can express or it can explain the mass of a substance that will combine or displace 1.008 grams of hydrogen or 8 grams of oxygen or 35.5 grams of the chlorine. For example, here zinc react with the H2SO4, that is acid, dilute acid. What happened? It can form the zinc sulfate and hydrogen gas will be liberated. So according to grams we can expression that zinc. So here zinc atomic weight is 65.38 grams. Here 65.38 grams of the zinc is displaced the 2.016 grams of the hydrogen. Okay, so from this we can calculate the equivalent weight of the zinc. So now for example here, how many grams of displaces? A number, which is a number. Equivalent weight is a number. So here for example here 1.008 grams of the hydrogen can displaces how much the equivalent weight of the zinc. Now from this we can calculate it. So 1.008 grams is divided by 2.016 grams into 65.38 grams. Okay, so from this we can calculate it, simplify, we get a number that is a 32.69 grams. Okay, so here we can say that the equivalent weight of this zinc is 32.69 grams. Okay, so we can say that it is a mass number. So this is a number, and it is a mass of the substances. It is a mass of the zinc that combines here displaces. So this grams of the zinc, how much? The 32.69 grams of the zinc displaces the 1.008 grams of the hydrogen. So this number is called equivalent weight of the substance. Okay, so this is this grams. So this mass is called equivalent weight of the zinc. Okay, so that is the beauty of the equivalent mass. Now here is also we can say that 49 grams of the H2SO4 is reacted with 40 grams of the NaOH to form a 71 grams of the sodium sulfate plus 18 grams of the H2SO4. Okay, so these nothing but these are the equivalent weight of the acid is 49, and the equivalent weight of the sodium hydroxide is a 40, and equivalent weight of the sodium sulfate is 71 grams, and the equivalent weight of the water is a 18 grams. Okay, so now next our task is how to calculate the equivalent weight for a substance. So here different substances containing the different equivalent masses. Okay, so first we will see the how to calculate the equivalent weight for a element or equivalent weight of element. And here another one is a, if the equivalent weight, it is only number, if the equivalent weight is expressed in grams, we call it as a gram equivalent weight. It is also called gram equivalent weight or mass. Gram equivalent weight or gram equivalent mass. Whenever the equivalent weight, for example this is the equivalent weight of the zinc, that is a 32.69. if it is expressed in the grams, we call it as a gram equivalent weight. So gram equivalent weight of the zinc is 32.69 grams. Okay, so sometimes he asked that what is the gram equivalent weight or gram equivalent mass? What is that? The equivalent weight. The equivalent weight is expressed in grams is called gram equivalent weight. So how much is the zinc gram equivalent weight? That is a 32.69 grams. Now we will how to calculate the equivalent weight of an element. So one of the principle is there, that is the equivalent weight of an element is equal to atomic weight or atomic mass is divided by valency. For example, we take a sodium element. How much is the equivalent weight of for sodium element? So we know that sodium element atomic weight is 23 and the valency is 1. So we know that you remember that once again, first group elements and the second group element, third group is nothing but 13 group element, and the 14th group element, and 15th group elements, 16th group elements, and the 17th group elements. So first group element valence is 1, second group element valence is 2, 13th group elements valence is 3, 14th group elements valence is 4, 15th group elements valence is once again 3, the 16th group is a plus 2, and the 17th group is plus 1 valence. You remember that. So this is for your convenient. Okay, so sodium is first group element, that's why valency is 1. So how much the equivalent weight of the sodium is 23. So equivalent weight of the sodium, equivalent weight of sodium. Next, equivalent weight of the magnesium. So magnesium atomic weight is 24. 12 protons, 12 neutrons are there, that's why total atomic weight is 24, but the valency is, it is a second group element, that's why its a valence is 2, that's why here 12 is magnesium equivalent mass or equivalent weight. Next you will get a aluminium. How much the equivalent weight? That is atomic weight is 27, and the valency is 3, 13th group elements. So here 9 is equivalent weight of aluminium. Next, second one is equivalent weight for ions. Equivalent weight of ions. For example, here sodium ion or sodium plus ion. How much here is also? The principle is molecular weight of ion is divided by charge, either cation or anion. Okay, so here sodium molecular weight is nothing but, or sometimes it is also called atomic weight or molecular weight. So here atomic weight 23, how much the charge is a plus 1, that means 1. So how much the equivalent weight of the sodium plus ions? 23. Now phosphate, that is a PO4 minus 3. So how much the molecular weight of the phosphate ion is a 95. Okay, so it is 95 is divided by how much the charge is a 3, that's why here 95, that is 31.6 equivalent weight, it is a 95 molecular weight of the phosphate ion. Next one is sulfate ion, that is SO4 minus 2. So how much is a 96 molecular weight sulfate ion, and how much the charge is a 2, that's why here for the next 8, 48 equivalent weight of the sulfate ion. So this is the equivalent weight for ions, sodium plus ions, phosphate ions, and the sulfate ions. Now how to define the equivalent weight for the acids? Sorry, here another example is also there, that is a bicarbonate HCO3 minus, it is a bicarbonate. So here total molecular weight of the ion is a 61, and the how much of the charge is a 1, that's why equivalent weight of the bicarbonate is a 61. Now how to calculate the acids, equivalent weight of the acids? So if you define the, or if you calculated the equivalent weight for acids is different, acids are bases. Okay, so now molecular weight of the acids, molecular weight of acid is divided by basicity. So now here define the basicity. Basicity means, so number of, here the number of replaceable H plus ions, the number of replaceable the number of replaceable H plus ions is called basicity. For example, here H2O is taken, sorry, HCl is taken. For example, here HCl is taken. Now we find the equivalent weight of the HCl. So here, to find the equivalent weight of the HCl, first we calculated the molecular weight of acid. How much the here? 36.5. Here hydrogen atomic weight is a 1 and the chlorine atomic weight is 35.5. So total 36.5, it is a molecular weight of the acid. Now here, how many H plus ions are replaceable? This one, only one hydrogen is replaceable. That's why here basicity, how much the basicity is a 1 basicity, because only one hydrogen is replaceable. So that's why equivalent weight of the HCl acid is 36.5. Next one is H2SO4 sulfuric acid. Now the structure of the sulfuric acid like this, already we know that in hybridization. So here OH. So how many SO4? H2SO4. This is the structure of the. So now we can find that how many replaceable ions are there. Here one replaceable ion is H plus ion. Here we replaceable. Replaceable is nothing but if the bond is break. So this is the OH bond. So this OH bond is break. So it is a negative charge. It is a positive charge. So this positive charge is replaceable by another ion, which for example Na plus ion is taken. Okay, replaceable. So here we called the replaceable H plus ion calls. The number of replaceable H plus ions are called basicity. Now here how many replaceable H plus ions are there? 2 replaceable H plus ions are there. That's why now molecular weight of the H2SO4 is a 98, and the how many here 2 H plus ions replaceable, that's why is it 2. So now the equivalent weight is 49. 49 is the equivalent weight of H2SO4. Next one is Aspartic acid, H3PO4. So the structure of the H3PO4 is it is a 1 oxygen and the OH. So how many replaceable H plus ions are there? 1, 2, 3. So that's why first of all molecular weight of the Aspartic acid, that is a 98. It is also 98. And the how many replaceable H plus ions are there? 3 H plus ions are there. And the molecular weight, equivalent weight 32.6. Now here this phosphorus acid is very important, H3PO3. So generally from this we can misunderstanding. So how many replaceable H plus ions? 3, actually 3. So according to H3 we can directly identify the 3 H plus ions are replaceable. But whenever you will draw the structure of the phosphorus acid, so here O, how many O's are there? 3 oxygens are there. So 1 OH and the H. So this is a very important for the phosphorus acid. Okay, so actually here H3 means directly మనం ఏమనుకుంటాము, H3 3 ఉన్నాయి కాబట్టి ఇక్కడ ఏమనుకుంటాము, replaceable H plus ions 3 అనుకుంటాం. But actually according to whenever draw this structure, how many? Only 2. So this bond will be break, here this bond will be break, but it is a cannot break because it is a strong bond. So that's why here you will find the, so this is a very important, find out the equivalent weight. So phosphorus acid, the molecular weight of the phosphorus acid is a 82, But how many replaceable H plus ions are there? Only 2. So this is not acceptable. Only 2 H plus ions are replaceable. Okay. So this is a very important. Once again repeat it. So don't confuse. ఇక్కడ మనం ఎన్ని హైడ్రోజన్స్ ఉన్నాయో అన్ని హైడ్రోజన్స్ అంటే అన్నిటికీ కూడా అన్ని హైడ్రోజన్స్ రీప్లేసబుల్ అని చెప్పరాదు. ఓకే. సో whenever we draw the structure of the acids, from this we can identify it. So which hydrogens are replaceable? Generally OH hydrogens are replaceable ions, remaining all are not replaceable because this bond is very strong. That's why it is a not easily replaceable. This hydrogen is not easily replaceable. But here oxygen is a high electronegativity. That's why here this bond is very weak. That's why H plus ions are replaceable here. Only this place and this place. It is not. Okay. So this is a very important. And from the question is rising here. The element or substance is given. Find out the equivalent weight. That is the task. You mainly focus on that. How to calculate the equivalent weight for substances which are elements or acids or ions or bases. Okay. So now second one is equivalent weight for bases. How to calculate the equivalent weight of bases. So here is also what is that formula is a molecular weight of the. So molecular weight of the. So directly I will write in abbreviation. That is a molecular weight of base is divided by acidity. Acidity means here replaceable of OH minus ions. How many? The number of OH minus ions are replaceable is called acidity of that base. Okay. For example, you take a NaOH. How many OH minus ions are replaceable? Only one OH minus ion is replaceable. And the molecular weight of the base is that is the sodium hydroxide is 40 and the replaceable of OH minus ions are 1. So that's why equivalent weight of the NaOH is 40. Next, equivalent weight of the magnesium hydroxide. So two hydroxides are there. That's why easily we can identify that replaceable of OH minus ions are 2. That's why here 29 equivalent weight of the magnesium hydroxide. The next one is aluminium hydroxide. It is a OH 3 replaceable OH minus ions are there. That's why here acidity is 3 and the molecular weight of the aluminium hydroxide is a 78. So from this equivalent weight of the aluminum hydroxide is 26. Now this is the information about equivalent weight for the bases. Now equivalent weight for the salt. Equivalent weight of salts. Okay. So what is that? The principle is a molecular weight of the salt. Molecular weight of the salt is divided by positive charge of the cation or negative charge of the anion. So anyone you taken only one, either cation charge or anion charge, but not taken as a both. Okay, you will see, understand, briefly understand. For an example is taken, that is a NaCl is taken. Okay, so in NaCl, Na plus and the Cl minus. So that's why molecular weight is, total molecular weight is a 58.5. But the charge you will taken either cation charge or anion charge. So how much the cation charge? I will take the cation charge, that is a 1. So equivalent weight of the NaCl is a 58.5. Next, if you take Na2CO3, so how much the cation charge? 2 Na plus, that means Na plus. Okay, but the how many 2 sodium ions are there, or anion charge? How much the anion charge is a -2. If you take the anion charge here, So here molecular weight of the salt is 106 is divided by anion charge is it 2, minus 2 is nothing but 2. So how many? 5, 53 equivalent weight of the salt, sodium carbonate salt equivalent weight is 53.